All right, this is a quick video on how to use this repository and a few pointers on how to get things working. So as you can see on the left, we have the requirements to get this repository working. I'm using Unity 2020.3.38, an older version of MRTK, the current ROS TCP connector, and so forth. I'm also using ROS Noetic in this for the inverse kinematics and using this repo called relaxedIK, and this runs in ROS. And then you can also use holographic remoting on the HoloLens too, so that you don't have to deploy this. If you just want to test it, you can just use holographic remoting. So first, what you'll need to do is create your workspace and clone the repositories, these repositories. So it'll look like this. So in my relaxedIK source workspace, I have these four repositories: the TCP endpoint, fetch ROS, this KDL parser, and then the relaxedIK. And then you'll want to build that. And if you have any problems with building, here are a couple pointers. So you might need to update your CMake version, which is what I had to do, or you might have to update the config.toml to 0.25, and that's something that might happen while you're running the rust build command. So if you look here, you're also going to have to install a bunch of different dependencies unless you already have them. And then you'll also need to follow these steps here to get started in the relaxedIK repository. And this is that build command, the cargo.build that you'll have to use. But one thing is, so when you go into your relaxedIK repository, the relaxedIK core, if you look at the cargo, here is where I changed the versions. And also, if you go into the config, you can see there's these different folders here. And in my repository for the fetch robot, I have all the config files. So you'll just need to copy this fetch config into this collision, this fetch file into the same folder, and do that for all of these. And then you'll want to update the settings. And that should be all you need to get this relaxedIK working with the fetch robot in Unity. And so then once you do that, you can do cargo build, and that will build the relaxedIK core stuff for ROS. Now, going back in Unity, these are the steps. So here in Unity, you're going to want to go to the scenes and open up the fetch relaxedIK scene. And a few things. So in this version, when you use the URDF importer, the fetch robot is going to have a bunch of different scripts attached to the robot, which you'll want to get rid of. So here you can see articulation body, URDF inertial, URDF link. You don't really need to get rid of all of them, just articulation body. But to get rid of the articulation body, you have to get rid of this URDF inertial. So like you do this. And you basically do that for every single component. You don't want the articulation bodies. You could either check them off or you can just delete them. I already have an example of what that looks like. So if you go here, every single link will not have that articulation body. Once you finish that, I'll delete that. You're also going to want to add to each joint that is going to be manipulated by the inverse kinematics. You're going to want to add this script called joint controller, which I created. So if you go to like torso, I add this joint controller. And then if you look at the URDF, you'll figure out if it's prismatic or if it's continuous or revolute. I think all I use is prismatic or revolute. Okay, so there's continuous. So I set it. And then you also want to set the axis it rotates on, and then whether it has any upper or lower limits. So here you can see that the lower limit is set as well as the upper limit, and this will all be based on the URDF. And so I have that on 8 different links that are going to be manipulated by the inverse kinematics. Here, if you go to the subscriber, I subscribe to the ROS topic, which will be the relaxedIK joint angle solutions. And I add each of the links that I am going to be updating. As well as that, you're also going to have this publisher script, which will take this base link. You'll need to add the base link of your robot. In this case, it's pretty self-explanatory. And then you're also going to want to add this pose reference prefab. And so if we go in here, you'll see that it's really just the end effector of the robot. But we'll use this to send the end effector position to ROS so that it can give us the inverse kinematics to update the joints. And so that'll be updating. And then you'll also want the transform. So this will automatically instantiate this prefab at the gripper link transform, and then publish this end effector link to the relaxedIK. You also want to have this ROS connection script, but this will all be set up in the scene for you. So looking at those files, this is the joint controller, which will have the upper and lower limits, and it sets each of the joint positions. This is the end effector pose goal publisher. So basically what it's doing is it's taking the pose ref prefab that I talked about, and it's setting that to 0, 0, 0, which is what the relaxedIK needs. So it's wherever the end effector starts in the 0 position will be 0, 0, and wherever it moves, the position will move accordingly. And so I do a bunch of transformations to get that going, and then I publish that message over this topic, relaxedIK end effector pose goals. And then the relaxedIK will calculate everything and send it back the joint angles solutions over this topic. And then I've hard-coded this for the fetch robot, so 0 through 8 joint positions. Some of them may be in the negative direction, some in the positive direction. So that's something I should probably update in the future to make it work correctly, but it's just not right now. Let's see. And that is all for that. So basically, if you follow all these directions, you'll end up, you'll want to have 3 different tabs open. So in ROS, so first I will launch the relaxedIK Rust. Then I'll launch the TCP endpoints. And then I'll need to do this ROS param set simulation time go. You'll see waiting for keyboard driver to be initialized. That's just waiting for an end effector goal position to be sent. So basically, you go into the scene. Ooh, it's a little slow. Sometimes it's slow, sometimes it's fast. I think it's because I'm recording right now. As you can see, it'll follow the robot's arm. And that's basically it. Let me know if you have any questions.